In this demonstration, I would like to investigate all available research data within the EPOS-Norway Portal along the mid-oceanic ridges. So I will start by creating mid-oceanic ridge project, which I already did, and then navigate to search and find pane. From here, I'm first interested in geophysical data. So here I see immediately I have aeromagnetic survey data, 2 data sets, so I'm adding them to my workspace. Then I will switch to display, and from here I will select map view. If I select the first data set, I can also see how big the dataset is. So it's almost 1 million of rows in the table, and I want to plot all the points in the map view. So I will choose longitude as x-axis and latitude as y-axis. It will take a while. Now it's parsing the data. And now we see all the data as red points. To distinguish the actual values, I will use the magnetic intensity as color scale. So now it's applied. So this is the latest dataset, the compilation. I would like to also see what was the coverage of the latest survey. So now I'll switch to the survey data Knipovich Ridge, and again do the same for this dataset, adding to the same map layer. I will just drag the longitude again to X and latitude to Y, and using the magnetic intensity as a color attribute. Okay. To distinguish between those two data sets, I will choose the different color map for the second data set. So if we zoom in, we can see the actual coverage of the latest survey. Let's try to add other data sets. First, go to search and find geophysical data, select the heat flow map, switch back to my display, and add a new plot to the second window, again a map plot. Here I want to visualize the heat flow map, so dragging longitude to X and latitude to Y, and the milliwatt per square meter I will use as color scale. And in addition, I want to add bathymetry, so I will just select the geophysical data WMS server and drag and drop the bathymetry Northeast Atlantic into this map. From the heat flow map, we see that there's actually increased heat flow close to the mid-oceanic ridge right here, and much lower for the continental part. On this view, I'm showing the previous data set before the new survey along Knipovich Ridge, and then on the right hand side it's the newly compiled dataset including the orange patch. It's definitely improving the resolution and covering the gaps from before. Switching back to the previous view, when I removed the large dataset just to make it a bit more responsive, one can also change the background layer to actually see the geographical features. So now we see how it's situated comparing to the mid-oceanic ridge. And we can also compare it to seismicity within the region. To add the seismic datasets, I will navigate back to Search and Find and filter by seismological data. And I'm interested only in earthquake lists. And now we'll look at all the data between 1980 to 2018 and add it to my workspace. Going back to display, for visualizing the seismicity, I will create a new display by clicking the plus button in the upper right corner, and I will change layout for this one to add 4 tiles. The first one I will use again as a map. I can choose and add a background to see also the geographical features, and then add the seismic events. Tracking latitude to y-axis, longitude to x-axis, use depth as color scale and magnitude as size attribute. Then I will adjust the legend. So I want to see the resolution for depths on down to 50 kilometers. And I will use the inverted thread, and also I will artificially decrease the depth, so having the better resolution of colors. I want to scale the magnitude between 0 and 20 to see all points as small dots. Now we can add scatter plot, use time as x-axis and magnitude as y-axis. Another scatter plot would be the depth against magnitude. And in the last, I'm interested in location errors in latitude and longitude. For the depth, I want to invert the direction of y-axis, have the depth increasing downwards. Then in the map, I'm interested in events around Tian Mayen, so I'm pressing Alt button, dragging the box along Tian Mayen and zooming in. And from there, I immediately see I have shallow earthquakes only. I can adjust the view and zoom in depth by pressing the middle button and dragging the mouse at the same time to increase the resolution in the selected area. Similarly, I can adjust the other plots. And let's say I'm interested in only very well located events. So I will zoom in the location error plot, pressing Shift and dragging the mouse. And also I want to specify exactly the filter. So I will use the location error in longitude from 0 to 20. And the same for latitude. So the number of events is decreased. And I also want to see how the events are showing in the map based on the depth view. So I will create yet another filter based on depth. So I'm pressing Shift and dragging the box in this plot. Again, I will edit the filter so I know exactly what is the depth range. So for the depth, I want to start at 0 by 2 kilometers and I can now drag this window to see where my earthquakes are located in depth, basically creating depth sections. Now I want to say I'm interested only in earthquakes down to 10 kilometers. I also might investigate evolution, making another selection and see where the events were located depending on time. If I want to cancel the selection in time, I can redraw the box and include all the data points in my plot, or I can set the values directly using the Edit Filter button. Once I'm finished with my selection, I can either download the data, for which I need to first add the table view, or I can simply save my project. But this is saving the project in a cache of the browser. So if I want to open it on another computer than this one, I want to download the project first. If I do so, it will ask me where to store JSON file, which is the configuration file, which I can then either send via email or store somewhere on the cloud and open it from any other computer.